Hi everyone, in this video I am going to solve O-Levels Additional Mathematics Paper 2 in a session October-November 2024 Paper 2-2. So let's start with the first question. Question number 1, solve the following simultaneous equations. So let's cross multiply this equation. This is 2y equals to 3x. And let me solve for y, which is equals to 3 by 2x. Let's say this is my equation 1 and this is my equation number 2. So we can say put equation 1 in equation 2. So equation 2 is y to the power 4. So means 3 by 2x to the power 4 over x to the power 5. This is 27 over 16. Cross multiplication is better. Okay, 3 by 2 to the power 4 first. 3 by 2 and its power, okay, 3 by 2 power is 4. 81 over 16. 81 over 16 x to the power 4, and it is multiplied by 16, and this is 27 is multiplied with x to the power 5. I cross multiplied, right? 16 is cancelled with 16. This x power 4 and power 4 is cancelled, just one power is left. So 81 is equals to 27x. All right, so let's solve for x. 81 over 27, this is my x. Okay, 81 divides 27, that is 3. So we have done with x value, which is equals to 3. Now we have to plug this x value into my first equation to solve for y. Put x in equation 1. So y is equals to 3 by 2x. All right, so y would be equals to 9 by 2. 3 times 3 is 9, so that's 9 by 2. So these are the values of x and y. Question number 2, variables x and y are related by the equation. All right, find dy over dx. So we have y, we have to find dy by dx. These are the product of two functions. So here we apply the product rule in derivative. Product rule of derivative. All right, so dy over dx, the product rule is first function is as it is, x is the first function and square root of 1 plus 2x is the second function. First function is as it is, take the derivative of the second function, which is 1 plus 2x to the power 1 by 2, plus the second function is as it is, and take the derivative of the first function, d by dx of x. Okay, so this is x, applying the power rule over here. So power base function power minus 1, and the derivative of the base function is 1 plus 2x, and here we have square root of 1 plus 2x, and the derivative dx or dx is just 1. All right, so for further simplification, let me use a separate sheet of paper. Question 2a part. Okay, remaining dy over dx is x, this is 1 by 2, 1 plus 2x, 1 minus 1 by 2. Sorry, I messed up over here. Power base power minus 1. So power is 1 by 2 and then minus 1. That is the rule. So this is minus 1 by 2. 1 by 2 minus 1 is minus 1 by 2. The base function derivative, one derivative is 0, 2x derivative is just 2, plus square root of 1 plus 2x. So further simplification, 2 is cancelled with this 2, x and this power is shifting to the denominator, so square root of 1 plus 2x plus square root of 1 plus 2x. All right, so that is the derivative of the function. Now for part B, it is given that when y is 12, x is 4. Find the approximate change in x when y increase from 12 by the small amount 0.06. So we have given that we have to find the approximate change in x Okay, when y increase from 12 by the small amount means delta, this small amount is delta y. So we have to find delta y over delta x is dy over dx at x is equals to 4. We have delta y, so 0.06 is delta y over delta x. Let me solve for dy by dx at x is equals to 4. So we have done with dy by dx, just substitute x equals to 4. So we have 4 over square root of 1 plus 2 into 4 plus square root of 1 plus 2 into 4. All right, so this is 1 plus 2 into 4 is 9 and square root of 9 is 3, right? So we have 4 by 3 plus 3 is 13 by 3. This is 4 by 3 plus 3. This is 13 over 3. All right. So let me solve for delta x. So delta x over 0.06 is 3 over 13. I did the reciprocal on both sides. So from here we have delta x, the approximate change in x. This would be 3 over 13 times 0.06. 3 over 13 times 0.06. This would be 9 over 650. Okay, 9 over 650, or we can say 0.01385. Now for part C, find the x coordinate of the stationary point on the curve. Okay, so for stationary point, we have to put the first derivative equals to 0. Keep this in mind. So we have done with the first derivative, which is x over square root of 1 plus 2x and plus square root of 1 plus 2x. This we have to put this equals to 0. We are just working with the x coordinate. Let me simplify. So x over square root of 1 plus 2x, this is equals to negative square root of 1 plus 2x. So cross multiply it. So x is equals to, this is in the product, so the square root of 1 plus 2x with a negative sign. All right, so x would be equals to minus 1 minus 2x. So x plus 2x, this is minus 1. So 3x is equals to minus 1 and x is equals to minus 1 by 3. So this is the x coordinate of the stationary point of the curve, minus 1 by 3. Question number 3, do not use a calculator in this question. Okay, calculator is not allowed. Keep it aside. The polynomial p is defined by, this is p of x, where a and b are constants. Number a, given that x equals to 2 and x equals to 1 are the roots of the polynomial p of x equals to 0, find a and b. So these are the roots of the polynomial. So p of x equals to 0. So these are the roots. It means p of 2 equals to 0 and p of minus 1 equals to 0, right? So make an equation p of 2 equals to 0. This is the root. Just replace x with 2, right? A, we have 2 cube, minus 3, we have 2 square, minus 3 into 2 plus b, this is equals to 0. This is 8a minus 2 times 2 is 4. 3 into 4 minus 6 plus b equals to 0. So 8a minus 12 minus 6 plus b equals to 0. 8a plus b and minus 12 and 6 with 18. So minus 12 and minus 6 is minus 18. This is equals to 0. So 8a plus b equals to 18. That is my first equation, right? Now let me do the second part. When we have the second root, sorry, calculator is not allowed again, but I was just using to show you, okay? I'm sorry for that. Negative 12 and negative 6 is negative 18, right? Now p of negative 1 equals to 0 because minus 1 is also the root over here. So just simplify. So a and negative 1 cube minus 3 negative 1 square minus 3 into negative 1 plus b equals to 0. So this is minus a minus 3 because this is minus 1 square is just 1 plus 3 plus b equals to 0. So positive negative 3 is cancelled out. We can say minus a plus b. This is equals to 0. That is my second equation. Now look at the two equations. We have b and b. The coefficient of b is just 1. So let's subtract equation 1 and 2. All right. 8a plus b is 18 minus a plus b is 0. Okay, so when we are subtracting, changing the sign, it's positive, negative, negative. This is cancelled out. 8a plus 8, this would be 9a, and this would be 18. And 9 times 2 is 18. So a value is equals to 2. Alright, now substitute the a value into my second equation. We can say put a in equation 2. So from here b is equals to a, b value is equals to a, so b value is 2. So b and a both are 2. So we have done with the values of a and b. Now for part b, solve the equation p of x equals to 0. Let me substitute the values over here and then we have to solve. So p of x, this is a is 2 x cube minus 3x square minus 3x and plus 2. This is my polynomial. We have to solve this polynomial by putting it equals to 0. First we have to convert, it's a cubic polynomial. Let me convert this into factored form. We will get 3 factors of this polynomial. So from first part we come to know that it has 2 roots, at 2 and at minus 1. So let me use a method of synthetic division over here. Right. We have to use this method. So write down the factors, the coefficients of x cube, x square, x coefficient, the constant term. 2 is the factor. Bring the first term down, right? 2 times 2 is 4. Add them up is 1. 2 times 1 is 2. Add them up. This is, sorry, this is minus. So this is just 1. 2 times 2 is, 2 times 1 is 2. When you can, it's negative 1. 2 times minus 1 is minus 2 and we have 0. Okay, so we have reduced to this one. All right, now further applying synthetic division method one more time, because we already know another factor which is minus 1 is another factor for this polynomial, minus 1. Bring the first factor down. Minus 1 times 2 is minus 2. When you add them up, you will get minus 1. Minus 1 times minus 1 is just 1. When you add them up, you have 0. Okay, so p of x is reduced into the factors. This is the cubic one. This is a quadratic and this is now linear. So 2x minus 1. The other two factors are x minus 2 and x plus 1. This is in the factored form, right? Now we have to put p of x equals to 0, means 2x minus 1 equals to 0, x minus 2 equals to 0, and x plus 1 equals to 0, and we have to solve for x. So from here the x value is 1 by 2, x is equals to 2, and x is equals to negative 1. So these are the 3 solutions. Question number 4, use a graphical method to solve the inequality. So for this inequality, let us suppose y equals to absolute of 2x minus 8 and y equals to 4. Okay, so we can say let y equals to 4 is the one equation, and the other is y equals to 2x minus 8, the absolute. Okay, consider this is absolute, it means it must be at the top, positive y values. So if I can suppose y equals to 2x minus 8, so here the slope is 2 and the y-intercept is negative 8. All right, so let me draw the lines. Y equals to 4, first we have to plot this line. Okay, this straight line is y equals to 4. All right, and the slope is 2. The y-intercept is negative 8. Here is the y-intercept, negative 8. The slope is 2. 2 means rise over 1. The slope is rise over 1. rise over 1. So this is 2 by 1. Rise is 2 unit and the run is 1 unit. So when we rise 2 unit, we are at this point, and when we run 1 unit, we have at this point. You can see rise 2 units, -8 to -7, and then -6, and the run is at 1 unit. So these are the 2 points. Let me draw the straight line. This at the bottom, this is just the dotted one because we are working with the absolute value, right? Okay. So its reflection is the absolute of the y-intercept is absolute of -8, which is positive of 8. So this is the shape of the graph. Y equals to 4 and absolute of 2x minus 8, right? Now we have to solve the inequality when this absolute function is greater than 4. At this part it is greater than 4. This is absolute function, right? This is less than 4 and this is more than 4. So at this portion it is more than 4. So we have to write it down. So as you can see, the absolute function and the line intersect at the point x is equals to 2 and at x is equals to 6, at 2 and 6, right? So when the absolute is more than 4, when the x values are less than 2 and more than 6, right? So the solution is, I can say, when x is less than 2 and x is greater than 6, absolute of 2x minus 8 is greater than 4. So this is the solution. Question number 5, solve the following equations. Part A, it's a logarithmic equation. The base is 2 and the base is 16. So let me make the same base 2 and 2. So log base 2 x square. Change of base formula is log base 2 over log base 2. So base is 2, we fixed. So x and 16, this is equals to 18. So now here log base 2x square plus we have log base 2x over, what is log 216? Let me use a calculator. Okay. All right, log base 2 and we have 16. This is 4 and equals to 18. So 4 log 2x square plus log 2x divides 4 equals to 18. Cross multiplication, 4 log 2x square plus log 2x equals to 4 times 18. 4 times of 18 is 72. Okay, this is log 2x square to the power 4 plus log 2x, and this is 72. Okay, let me simplify this further. We have log base 2 x to the power 2 times 4 is 8 plus log base 2 x equals to 72. Now log base 2, we have x to the power 8 and x, and these are in the sum, so we can do the product 8 and this is 1. This is 72. When bases are same, we can add the powers. Log base 2 x power 9 equals to 72. Now converting the log into exponential. So here x power 9 is 2 to the power 72. Okay, so let me take power 1 by 9 on both sides to solve for x. This is 2 to the power 72 by 9 is 8. And 2 to the power 8 is 256. This is the value, solution for x. Now for part B, we have to solve this exponential equation. E to the power 2x plus 1 minus 10. E to the power minus is common, 2x plus 1 equals to 3. So e to the power 2x plus 1 minus 10 divides e to the power 2x plus 1, shifting this to the denominator to make it positive, equals to 3. LCM e to the power 2x plus 1, its whole square, minus 10, and this is equals to 3 e to the power 2x plus 1. Okay, so e 2x plus 1, this whole square, minus 3 e 2x plus 1 and minus 10 equals to 0. This look like a quadratic equation. You can see 1 times 10 is 10. Okay, we have to find the factors of 10, so I guess it's not possible. 2 times 5 is 10. 2 and 5, it's, yeah, 2 and 5 works, yes. So e to the power 2x plus 1, its whole square. 2 times 5 is 10. 5 times 2 is 10. And if I can do 2 minus 5, this is negative 3. Let's break 2 and minus 5. 2 e to the power 2x plus 1 and minus 5 e to the power 2x plus 1 minus 10 equals to 0. All right, let's take e to the power 2x plus 1 common. We are left with e to the power 2x plus 1 and plus 2. Let's take negative 5 common. E to the power 2x plus 1 and 5 times 2 is 10 equals to 0. Now we have some factors. E to the power 2x plus 1 plus 2 is the factor, and e to the power 2x plus 1 minus 5 is the factor, equals to 0. Let me solve on a separate sheet of paper. Okay, the fourth factors, put it equals to 0 separately. E to the power 2x plus 1 minus 5 equals to 0. E to the power 2x plus 1, this should be minus 2. And e to the power 2x plus 1, this should be equals to 5. Right. So this is negative 2, so we cannot get no solution. Why it has no solution? Because we have to apply a convert the exponential into logarithm. When we convert it, you will get, taking ln on both sides, ln e to the power 2x plus 1, ln of negative 2. So ln of negative 2 does not exist, so we have no solution from here. Let's check, taking ln on both sides. So ln e to the power 2x plus 1 equals to ln 5. So the power comes before the log. 2x plus 1, ln e equals to ln 5. Ln of e is 1. So 2x plus 1 equals to ln 5. So 2x equals to ln 5 minus 1. And x would be equals to ln 5 minus 1 divides 2. So this is a value for x. Or we can do in decimals, ln 5 minus 1 divided by 2, x is equals to 0.305. Okay, question number 6. Do not use a calculator in this question. Again, write this number in the form of a plus b root 3, where a and b are constants. This is negative 2 power, write down in the denominator. 5 minus root 3 divides root 6 plus root 2, its whole square. All right, so let me simplify this further. This is 5 minus root 3 over, open the square, a plus b whole square, the first term square, plus 2 into the first term into the second term plus the second term square. So this is cancelled out, this is cancelled out, which is 5 minus root 3 over 6 plus 2. This is 2 times 6 or 6 times 2. So square root of 12 plus 2. So here we have 5 minus root 3 over 8 plus 2 root 12, because 6 plus 2 would be 8. So we have to write this down in this form. So let me rationalize it. Or it should be in the root 3. So before rationalizing, we have to convert this into root 3. Okay, so 5 minus root 3 over 8 plus 2. 12 is 2 times 2 is 4, and 4 times 3 is 12. This is 5 minus root 3 over 8 plus 2. So bring the 2 down. It's a square. And root 3. So this is 5 minus root 3 over 8 plus 4 times 2 times 2 is 4 root 3. Now we can rationalize it. With the conjugate of the denominator, we have to rationalize it. Multiplying and dividing with the conjugate of the denominator. Further simplification, we have multiplied 5 minus root 3 is multiplied with 8 minus 4 root 3, and in the denominator we have a plus b and a minus b, so we have to use the formula of first term square minus the second term square. So let me write down. When we have the factor a plus b and a minus b, so use the formula of difference of square. Okay, for this simplification, 5 times, okay, 5 is multiplying with the bracket, minus root 3 is multiplying with the bracket, and in the denominator 8 times 8 is 64, 4 times 4 is 16, and this is just 3 because root and the square root is just 3, right? So 5 times 8 is 40, 5 times 4 is 20 root 3, minus 8 root 3, and minus would be plus. We have 4 root 3 into root 3 is just 3, or root 3 square we can say. In the denominator we have 64. Okay, 16 times 3, calculator is not allowed. 3 times 6 is 18. 3 times 1 is 3 and 4, 48, minus 48. This would be, okay, 40. Minus 20 and minus 8 is minus 28 root 3, plus this is cancelled out. This is 12 over, we have 64, take away 48. So here we have 5 and we have 14. From a 14 take away 8, 8, 9, 10, 11, 12, 13, 14. This is just 6, and 5 take away 4 is 1, it's 16. Okay, 40 plus 10 is 50, plus 2 is 52. So we have 52 minus 28 root 3 divided by 16. We need a further simplification. This would be 52 over 16 minus 28 over 16 root 3. Okay, cancel this out. 2 times 2 is 4, 2 times 6 is 12, 2 times 8 is 16, 2 times 1 is 2, 2 times 3 is 6, 2 times 4 is 8. 2 times 1 is 2, 2 times 4 is 8, 2 times 4 is 16, 2 times 8 is 16, sorry. 2 times 7 is 14, and 2 times 4 is 8. The simplified answer in the form of a plus b root 3, this is 13 over 4 minus 7 over 4 root 3, where a and b are constants. These two are the constants. Question number 7. A class of 10 students includes Abby and Ben. Part A. A group of 5 students is to be selected from the class. Find the number of possible groups in the following cases. Number 1, there are no restrictions. So the number of students to choose, the number of ways to choose 5 students, a group of 5 students out of 10 students in the class, we have to use the combination formula 10C5. We have 10C5 is 252. So there are 252 ways to choose a group of 5 students out of 10 students. Okay, number 2, a group includes both Abby and Ben. All right. So if a group must include both Abby and Ben, we need to choose 3 more students from the remaining 8 students. It means out of 10 students, right, 8 are any other students, but the 9th and the 10th are Abby and Ben. So from if the group includes both Abby and Ben, so we have to consider 8 students. And here we have to consider 3 students, right? If the group must include both Abby and Ben, so we need to choose 3 more students from the remaining 8 students. So this can be done in 8C3 ways. 8C3 is 56 ways when the group includes both Abby and Ben, right? Now for part 3, the group includes either Abby or Ben but not both. Alright, so if the group includes either Abby or Ben but not both, so we consider 2 cases. Alright, so in case 1, let's say the group includes Abby and not Ben. Alright, so we have to choose 4 students from the remaining 8 students, right? So 8C4 out of total, before we have 10 students, so Abby and Ben are excluded, right? We have to consider them as a 1 unit, right? And from 5 we are taking only Abby, so 4. Okay, so 8C4, this is 70. And for case 2, let us consider Ben and not Abby. So if the group includes Ben but not Abby, so again we have to choose 4 students from the remaining 8 students. So 8C4, which is 70. So the total would be equals to 70 plus 70 is 140 ways. All right. Now for part B, all 10 students are arranged in a line. How many arrangements are possible if there are exactly 3 students between Abby and Ben? Okay, since Abby and Ben have exactly 3 students between them, so they can be in positions 1 and 5, or we can say 2 and 6, or another position it can be 7, 8 and 3 and 7, because there must be 3 students. So 1, 1, 2, 3, and then 5, 1, 2, 3, 4, and then 5. At 2 we have 3, 4, 5, and then 6. At 3 we have 4, 5, 6, and then 7. Or at 4, 5, 6, 7 we have 8, 4 and 8. Or we can say 5 and 9, and we can say 6 and 10. Okay, so how many positions we have? 1, 2, 3, 4, 5, and 6, right? So there are 6 positions for them. There are 6 positions for them. All right. Okay, so since their order could be different, Abby followed Ben, or Ben followed Abby, right? So the total positions could be the 2 times of 6. So we can say since their order could be Abby followed Ben, or Ben followed Abby. So how many positions we have? Now we have 2 times of 6, which are 12 positions, or 12 different ways. All right. Okay, and there are 8 people, can be anywhere. The other 8 students, other than Abby and Ben's, the other 8 students can be anywhere. because we have no restriction on the other 8 students. Okay, and their number of arrangements and the number of arrangement is 8 factorial ways. So this implies we have 12 times 8 factorial ways. Okay, so what is 12 times 8 factorial? Yeah. For 8, 483,000. 483,840 ways we can arrange the students in the line when there are exactly 3 students between Abby and Ben. Question number 8, solve this equation. So let me convert the cot into cos over sine and cosecant into 1 over sine. Cos square 2 theta over sine square 2 theta plus 3 into 1 over sine 2 theta. This is equals to 9. All right, so let me take sine square 2 theta as an LCM. So we have cos square 2 theta plus 3, this one is multiplied, yes, sine 2 theta and divided by sine square 2 theta equals to 9. Now cross multiplied, cos square 2 theta plus 3 sine 2 theta equals to 9 sine square 2 theta. All right, so let me convert, this is in sine, this is in sine, this is in cos. So simplify, use the identity, cos square theta plus sine square theta equals to 1, and what is cos square theta, which is 1 minus sine square theta. Put the value over here. So cos square 2 theta is 1 minus sine square 2 theta plus 3 sine 2 theta minus 9 sine square 2 theta equals to 0. Shift this term on the other side as well. So these are 2 sine square. So minus 9 and minus 1 would be minus 10. Minus 10 sine square 2 theta plus 3 sine 2 theta and plus 1 equals to 0. Let me take negative sign common throughout the equation. Alright, so this is 10 sine square 2 theta plus 3 sine 2 theta plus 1 equals to 0. Okay, if I factorize this, we have 10 times 1 is 10. So factors are 2 times 5 is 10. And we can say 5 minus 2, this is 3. Break the midterm. 5 minus 3, so 10 sine square 2 theta plus 5 sine 2 theta minus 2 sine 2 theta plus 1 equals to 0. So let me take 5 common and sine 2 theta common. 5 times 2 is 10 and sine 2 theta is left plus 1. Take negative 1 common, 2 sine 2 theta and minus plus 1. Wait a second. Here we are taking negative sign common. So this is positive, this becomes negative, and this becomes negative. So minus 3, how can we make? Minus 5 and plus 2 becomes minus 3. Minus 5 and plus 2. And this sign is also negative. So you will get minus. Take plus and you will get minus. Yes, now the factors are same. I was also thinking I did some mistake, I guess. So 5 sine 2 theta plus 1 is the factor, and 2 sine 2 theta minus 1 is the factor. Put both factors separately equals to 0. this factor is 0, and the other factor 2 sine 2 theta minus 1, this is equals to 0, right? So let me solve for theta. So sine 2 theta is minus 1 over 5. Here sine 2 theta would be 1 by 2. All right, so what is here? Sign is negative and here sign is positive. So using the cast rule, we have to check sign is positive and negative in which quadrant. Okay, use the cast rule. This is C, A, S, and T. So sign is positive in the first and second quadrant and negative in the third and the fourth quadrant. So here sign is negative. Sign is negative in third and fourth quadrant. And here sign is positive, so we can say sign is positive in first and second quadrant. All right, so let me simplify. So 2 theta, this would be sine inverse of 1 by 5. This is in degrees. My calculator is in degrees. Sine inverse 1 by 5 is equals to this much. So 2 theta would be 11.54 if I round it degrees. Okay, now for the third quadrant, what is the operation for the third quadrant? 180 plus this value, 180 plus answer. Okay, so for the third, we have two solutions for the third and for the fourth quadrant. For third quadrant, 2 theta is 191.54 degrees. And for the fourth quadrant, we do 360 minus 11.54. This is 348.46. 2 theta is 348.46 degrees. Okay, check the rest. Next one, 2 theta is sine inverse of 1 by 2. Okay, sine inverse 1 by 2 is 30. So 2 theta is equals to 30 degrees. Okay, and this is in the first quadrant, and in the second quadrant its operation is 180 minus that angle. So 2 theta is equals to 150 degrees. All right, so these are the four values of 2 theta we have. So 2 theta is equals to 191.54 degrees, 348.46 degrees, we have 30 degree and 150 degree. And in the question we have given that the theta value must lies between minus 90 degrees to plus 90 degrees. All right, so in these 2 theta values, let me subtract 360. So 2 theta minus 360 degree or 2 pi. All right, in all these values, let me do 1915.54 minus 360. This is minus 6168.46, because as you can see, we're getting all the positive values. That is why I'm just subtracting minus 360. If we add, you can also add 360 as well, but you will not get any solution. All the values are more than the range. Okay, so 348.46 minus 360, this is minus 11.54. We have 30 minus 360 minus 330, and 150 minus 360 is minus 210 degrees. Okay, so these are the rest of the values for 2 theta. So these 4 and these 4, so total 8 values. So we can say what are the solutions. So what is theta? In all these values we have to divide it by 2 and we have to pick the solution which lies in the given range. Okay, so let's see the values of theta. every time dividing by 2. 191.54 divided by 2, this is 95.77, it is more. 348.46 divided by 2, 171 is also more than the range. 30 divided by 2, it is 15, it is in the range, so 15 degrees the solution. What else? 150 divided by 2 is 75 degrees the solution. This one is minus 168.46 divided by 2, minus 84. This is the solution, 0.23. Minus 84.23 degrees is the solution. Minus 11.54 divided by 2, so minus 5.77. This is in the solution. Minus 330 divided by 2, no, it's not in the solution. Minus 210 divided by 2, this is not in the solution. So these are the 4 solutions. Question number 9. In this question, time is measured in seconds. Part A. A particle is moving in a straight line with the constant velocity 6 meter per second. It moves in a straight line, right? So this is a velocity time graph. The velocity is 6 meter per second. It is moving in a straight line. At t equals to 0, when the time is 0, it passes through the fixed point A. At t equals to 5, it suddenly changes direction between 0 to 5, right? When the time is between 0 to 5, the particle moves with a constant velocity of 6 meter per second, right? So this is represented by the horizontal line at v equals to 6. Okay. Okay, at t equals to 5, it suddenly changes direction. When it changes the direction, what does this mean? It means the velocity becomes negative now. Now the velocity is not positive, it becomes negative, all right, and moves with a different constant velocity along the same straight line. It passes through point A again at t equals to 15. When the time is 15, sketch the velocity time graph. Okay, the particle passes through point A again at t equals to 15. Okay, so keep in mind the displacement is 0 between t equals to 0 to t equals to 15. Okay, and what is the area under the velocity time graph represent? This is a velocity time graph. The area under the velocity time graph represents the displacement, right? So let me find out the area of this rectangle between 0 to 5. So we can say area of rectangle between 0 to 5 we are working, which is length times width. So this is 0 to 6 is 6, and 0 to 5 this is 5, and this is equals to 30. All right. Okay, so the area of the rectangle between 0 to 5 is 30. So the area of rectangle between 5 to 15, this must be equals to negative 30. So we can say area of rectangle between 5 is less than equals to t is less than equals to 15 is equals to negative 30 to make the displacement equals to 0, right? Why the displacement is 0? The displacement is 0 between 0 to 15 because the particle changes direction and it moves along the same straight line, and it again passes through point A. That is why. So this is a reason. Okay, now let me find out the area of the rectangle we have. Let me use this formula. Area of a rectangle is negative 30, and its formula is between 5 and 15. This length is between 5 and 15 is 15 minus 5, and we have no idea about the velocity. Let's say it is velocity 2, and solving for the velocity 2, minus 30 divided by 10 is velocity 2. So negative 3 is the next velocity. So we have the horizontal line negative 3. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So here we have negative 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, this is negative 3. between 5 to 15 we have to draw the straight line when the velocity is -3. So this is the velocity time graph for the motion. Let me explain you guys one more time. So in the question we have given that the particle moves in a straight line. It is moving in a straight line with a constant velocity of 6 meter per second, the velocity we have given. At t equals to 0, it passes a fixed point A. At t equals to 5, it suddenly changes direction. Means between 0 to 5, it moves in a straight line with a constant velocity of 6 meter per second. Right, the first part is done. Okay, at 5 it changes direction. Direction change in velocity, it means the velocity is negative. Before the velocity is positive. Now when the direction changes, it means the velocity must be negative over here. All right, and the displacement becomes 0. Okay, and moves with a different constant velocity along the same straight line. It must be a different constant velocity. So we have to work for this velocity. It passes to point A again at t equals to 15. At t equals to 0, it passes through fixed point A. At t equals to 15, it again passes through A. So at t equals to 0 it passes through A, at t equals to 15 it passes through A. It means the displacement would be equals to 0, right? So when the displacement is 0, it means in velocity time graph, area under the curve is represents the displacement. All right, so it means the area under the curve between 0 to 5 and between 5 to 15 must be opposite of each other, so to make the displacement 0. So this is the main concept in this question. So we have to first find the area under the curve, area under the curve under the velocity time graph, basically between 0 to 5. So it is a shape of a rectangle. So this is length is 6, this length is 5, so its area is 30. So the area between the interval 0 to 5 is 30. It means between 5 to 15 it must be -30. Why it is -30? Because we have to make the displacement equals to 0. Why? Because at t equals to 0 the particle is at fixed point A, and at t equals to 15 it again passes through the fixed point A. It means the total displacement must be equals to 0. 30 and -30, you have to make the displacement equals to 0. And in velocity time graph, area represents the displacement. So when you add the two displacements, that must be equals to 0, right? Okay, now the second area between 5 to 15, this must be equals to -30 with the help of the displacement. We come to know that, so we have to find out the second velocity and draw this. All right, I hope this makes sense. Now moving to part B. Another particle is moving in a straight line with a constant acceleration. Now the acceleration is constant. At t equals to 0, it passes through the fixed point B. When time is 0, it passes through the fixed point B with the velocity -8 meter per second. So this is again a velocity time graph. At t equals to 0, it passes through the fixed point B with the velocity -8. So when time is 0, the velocity is -8. It's the first coordinate we got. So -1, -2, -3, -4, -5, -6, -7, and -8. This is -8. This is my first point, right? It passes to point B again at t equals to 20. When t equals to 0, it passes through point B. At t equals to 20, it again passes to point B. The same thing. So when the particle passes through the fixed point B at t equals to 0, and it returned to that fixed point B at t equals to 20. What does this mean? The displacement is equals to 0. Right? So when the displacement is 0, we have to sketch the velocity time graph. All right. So we have acceleration concept used over here. So we have to use the equation of motion. So let me use the equation of motion over here, which is S is equals to ut plus half a t square, where a is the acceleration, t is the time, u is the initial velocity, and s is the displacement. Now in this case, the displacement is equals to 0, s is equals to 0. Why? Because at t equals to 0, it passes through the fixed point b, and it passes through the fixed point b again at t equals to 20, right? Since the particle returned to the point b at 0, it passes through b, and it returned to b at t equals to 20, so the total displacement would be equals to 0. So just substitute the displacement, right, equals to 0, and we have to substitute the point, which is the initial velocity is 0 and minus 8 is, sorry, the displacement is 0. You come to know the reason. And the initial velocity is negative 8. You know the initial velocity is negative 8, and the time we are taking is 20 now, not this point, sorry. Just substitute and simplify and solve for the acceleration here. So the displacement is 0, initial velocity is negative 8, and time is equals to 20 plus half. We have acceleration a, and time is 20 square. All right, so this is half a, 20 square is 400, equals to 8 times 20, shifting this term on the other side. So let me solve for the acceleration. 8 times 20 is 160, over 400 divided by 2 is 200. 160 by 200, this is 4 by 5, so the acceleration is 0.8 meter per second square is the unit for the acceleration. So we have to use this acceleration to get the value of velocity when time is 20, right? So equation for velocity, you have to remember this equation of velocity. V equals to the initial velocity plus acceleration and the time. So V, the initial velocity is negative 8, the acceleration we got is 0.8, and the time is 20. So what is the velocity at time equals to 20? Let me simplify. 20 times 0.8 and subtract 8. So the velocity is equals to 8. Okay, so at 20 the velocity is 8, this point. So let me draw the straight line. All right. This point is negative 8. Oh, sorry, positive 8. All right. So let me explain this question one more time as well. So the same concept we are using for like the part A, that at t equals to 0, it passes through the fixed point B, and at t equals to 20, it again returns to that point B. It means its whole displacement is 0. So they are talking about the acceleration. So it means we have to work for the acceleration. So we have to use the equation of motion. S is equals to ut plus half at square. So S is the displacement. We know that displacement is 0. U is the initial velocity, and we know the initial velocity is negative 8. T is the time at 20 seconds, right? So we have to work for the acceleration at 20 seconds. So this would be the acceleration. Now the next thing is we have to find the velocity, because it is a velocity time graph, not the acceleration graph. So use the equation of velocity when we have initial velocity, acceleration, and the time, and solve for the velocity. Question number 10, the diagram shows the part of the curve and the line. The curve and the line intersects at point A. This is a curve and this is a line. They intersect at point A, right? Now for part A, the maximum point on the curve is, this is a maximum point on the curve. The maximum point on the curve is at the perpendicular distance h from the line y equals to -4. This is at the perpendicular distance y equals to -4. Find the value of h. We have to find this perpendicular distance. All right, so first we have to work for the maximum point. So what is the maximum point? Maximum point is basically the turning point or the stationary point or whenever the question is about the maximum point, minimum point, turning point, stationary point, for these four words we have to take the first derivative and put it equals to 0 and solve, find out the coordinates basically. Okay, so for the maximum point, we have to take the first derivative of the curve. What is y prime for this curve? So this curve, its x derivative is 1, minus 1 by 4 is constant, x square derivative is 2x. 2 times 1 is 2, 2 times 2 is 4, so 1 minus x by 2 is the first derivative. So for maximum, you have to put the derivative equals to 0 and solve for x. So 1 minus x over 2 equals to 0. So 1 equals to x by 2, cross multiplication 2 is equals to x, right? So when x is equals to 2, what is the y? So y would be equals to 2 minus 2 square over 4. So y would be equals to 2 minus 4 by 4, which is 2 minus 1, which is equals to 1. So we can say the maximum coordinates are 2 and 1. So the x coordinate is 2 and the y coordinate is 1. So here x is equals to 2 and here y equals to 1. All right. Okay. Now the question is, we have to find the perpendicular distance, right? This distance. Here the y is 1 and here the y is negative 4. So we have to find this distance. Okay, 1, 0, negative 4, negative 3, negative 2, negative 1. Okay, how much unit is the distance? 1 unit, 2 unit, 3 unit, 4 unit and 5 unit. So h is between 1 and minus 4. This is equals to 5 units. The distance is 5 units. So we can say the maximum point on the curve is at the perpendicular distance h from the line y equals to negative 4, and that perpendicular distance is 5 units. Now for part B, find the exact x coordinates of A. So what is A? A is the point where the line and the curve intersect. Okay, so I'll find out the x coordinate. So we have to find point of intersection of line and curve. So the curve is y equals to x minus x square over 4 and the line is y equals to negative 4. Okay, so x minus x square over 4 equals to negative 4. So 4x minus x square over 4 equals to negative 4. 4x minus x square equals to negative 16. 4 times 4 is 16. Further simplification, shifting all the terms on the other side, 0 would be equals to x square minus 4x minus 16. Okay, let me apply the quadratic formula over here. So x is equals to negative of the b value plus minus square root b value square minus 4 times the a value and the c value divides 2 times of the a. X would be equals to 4 plus minus, simplify, negative and negative is positive, 4 times 16 we have, plus 4 square is 16, so root 80, which is 4 root 5 divided by 2. So we have two x values with a positive and with the negative. So further simplification, we have 2 plus minus 2 root 5. If we can take 2 plus 2 root 5, this is 6.47, and 2 minus 2 root 5 is minus 2.47. So this is on the positive side of the x-axis, not on the negative side. So we have to pick the positive one. So the x coordinate of A is, this x coordinate of A would be 2 plus 2 root 5. We have no idea about the y. We are just finding for the x. The exact x coordinate of A are with the positive one. We can say x is equals to 2 plus 2 root 5. Yes. Now for part C, find the acute angle between the tangent to the curve at A and the line y equals to -4. Tangent to the curve at A. Tangent to the curve at A. This is tangent to the curve at A. And this line, this acute angle theta, we have to find. Okay, so keep in mind, tangent theta is basically the gradient of the curve, right? So this is the tangent at point A. We have to find the angle, the acute angle between the tangent to the curve at A and this line. Tangent and this line, this acute angle. So tangent theta is always equals to the gradient of the curve at this point, right? Okay, so we can say tan theta is equals to the gradient, right? So here tangent theta would be equals to the gradient. It means y prime at x is equals to 2 plus 2 root 5. This is the x coordinate for A, right? So we have done with y prime. So tan theta is equals to, what is y prime? 1 minus x by 2 is the y prime value. Solve it at x is equals to 2 plus 2 root 5. Okay, so tan theta, this would be equals to 1 plus 1 minus 2 plus 2 root 5 divided by 2. So tan theta is equals to 1 minus 1 plus root 5. Okay, so we can cancel this out. So tan theta, this would be equals to 1 minus root 5. Cancel it out. So theta would be equals to tangent inverse of minus root 5. Let me solve for this. Tangent inverse of square root of 5 is theta is 65.9 degrees, or do this in radians as well. Tangent inverse of root 5, 1.15. Theta is 1.15 radians. So this is the acute angle, which is less than 90 degree or less than pi by 2. Question number 11. In this question, I is a unit vector in positive x direction and j is a unit vector in positive y direction. Time is in seconds and distances are in meters. The diagram shows the initial positions and velocities of two particles A and B that moves in xy plane. The initial positions and the velocities. Particle A starts from the origin O. This is initial position at t equals to 0. It moves with a constant speed, which is 10 meter per second, in the direction 60 degrees about x-axis, above x-axis. Number A, find the exact value of the components of velocity of particle A in the x direction and the y direction. Okay, so velocity vector we have to find. So the velocity vector is basically the velocity at x component plus I unit vector and velocity y component j unit vector. So here we have to just find the component y. So velocity, the x component of the velocity, this is basically speed multiply cos of angle theta, and the y component of velocity is speed multiply sine of angle theta. So the speed is 10 and theta is 60 degree. Here the speed is 10 sine of 60 degrees. All right, my calculator is in radians. Convert them into degrees. Cos of 60 is 1 by 2 times by 10. This is equals to 5. And sine 60 times by 10 is 5 root 5. So we have the exact value of the components of the velocity in the x direction and in the y direction. This is in x direction and this is in the y direction. All right, now for part B, find in terms of t the position vector of particle A at t time t. So the formula for the position vector of A, this would be equals to position vector of initial plus the velocity vector of A. D times the velocity vector of A. This is the formula, right? So position vector of A, this would be equals to what is the initial vector for A. Initially it is at origin, this would be equals to 0 0. So the initial vector is 0 0 plus t times the velocity vector. The x component is 5, the y component is 5 root 5. Is that root 5? It's root 3. I messed up. This is root 3. This is the position vector for A, which is 5t or 5 root 3t. Yes. Particle B starts from point this. This is the initial of the particle B at t equals to 0, right? So let me show you the diagram. This is initial position for the particle B. Okay. It moves with a constant speed. We have the speed for the particle B parallel to the positive x-axis. It's positive x-axis. It means the theta must be equals to 0. In this direction, the theta equals to 0. Theta is equals to 0 degrees. Now for part C, find in terms of t the position vector of particle B at time t. Okay, so the position vector of particle B is again the position vector of initial plus t times the velocity vector of B. Initially the position vector is 2 root 3 and 9 plus t times the velocity vector. So the formula for the velocity vector is x component speed, which is 5 by 3, and cos of theta, and speed and sine of theta. Because it is parallel to x-axis, that is why theta must be equals to 0. So cos 0 is 1 and sine 0 is 0. So this term would be 0. This is 2 root 3 9 plus t 5 by 3 and 0. Or we can say this is 2 root 3 plus 5 by 3t and 9. This would be the position vector for the particle B. Now for part D, hence show that the particles collide. So when the particle collide, it means the position vector of particle A must be equals to the position vector of particle B, right? So this is a position vector for B. We have done with the position vector of A as well. Put them equal. This is 5t and 5 root 3t. This is equals to 2 root 3 plus 5 by 3t and 9. Okay, put them equal and solve for the time. So 5t equals to 2 root 3 plus 5 by 3t, and we can say 5 root 3t, this is equals to 9. Let me solve for time. 5t minus 5 by 3t, this is 2 root 3. What is 5 minus 5 by 3? 5 minus 5 by 3, 10 by 3t. 10 over 3t is 2 root 3. Simplify, t would be equals to 2 root 3 and the reciprocal is 3 over 10, right? So 2 times 5 is 10, and here we have t is 3 root 3 over 5. And on the other hand, solve for t. T is equals to 9 over 5 root 3. Rationalize, multiplying and dividing by root 3. So t is equals to 9 root 3, and in the denominator we have 5 root 3 whole square. This is cancelled out. T would be equals to 9 root 3 over 5 times 3 is 15. 3 times 3 is 9. 3 times 5 is 15. So t is equals to 3 root 3 over 5. So as you can see, both the times are same. So we can say, since time is same, so particles collide. All right. Question number 12. A metal tank is in the shape of a cuboid with a square base of side x meter and an open top. Let me draw the cuboid. Let me draw the shape of the cuboid. Okay, so that's the cuboid. It's a metal tank and it is a shape of a cuboid and the base is squared. This is a square base. All the sides are x, 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 and x. And this top is open. Right. The tank has a volume of 5 meter cube. Okay. So we have given the volume of cuboid. This is equals to 5. The formula for volume of cuboid is length, width, and height. This is equals to 5. Right. Okay. So the length, width, and this would be the height. X times h is 5. We have to solve for the height, which is 5 over x square. This height is 5 over x square for the height, right? Okay, given that x can vary, that the area of the metal used to make the tank is minimum. Find the dimensions of the tank. Okay, so area, they're talking about the area of the metal used. It means we have to find the total surface area. Total surface area. So what is the total surface area in this case? As you can see, the bottom is a square. So its area is x times x plus we have 4 rectangles. So we have to find the area of 4 rectangles, the length and the width. So x times 5 over x square. This would be the total surface area, right? So A would be x square plus this and this x is cancelled. 4 times 5 is 20 over x, right? So it is minimum. They are also saying for minimum we have to take the first derivative and put it equals to 0. For minimum, a prime should be equals to 0, the derivative of area. So what is a prime? Its derivative is 2x plus 20. We can write this down as x square plus 20x to the power minus 1. So its derivative is minus 1 power base power minus 1 and the derivative of base is just 1. So here a prime is 2x minus 20 over x square. Now put this equals to 0 and solve for x. So 2x is equals to 20 over x square, right? Cross multiplied. So this x and x square would be x cube. 2 and 20 would be 10, right? We have given x can vary, so x should be equals to the cube root of 10. So the cube root of 10 is 2.15. Right. So we have to find the dimensions of the tank. So x is 2.15, this x is 2.15. What is the height? So the height is 5 over x square, which is 5 over 2.15 whole square. Okay, the square 5 divide answer is 1.077. So we can say the dimensions of the tank are this is 2.15, this is 2.15, this is 1.077. Yes, so these are the three dimensions. All right, so that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.